Hello, welcome to the machine learning at home. One of interesting question about cluster analysis is how repeatable is it if the initial data changes. So if data is changed somehow, clustering results will also change. So this is actually very bad. So there are many robust methods of clustering analysis which are supposedly do not change result much if the initial data change it. One of robust methods is implemented in a package tclust. So let me show how it works. Library tclust. So you need to install tclust if you have any error when you type this library tclust. So like type install.packages tclust in quotes and then type library tclust as I just did. So now we can apply this trimmed clustering. So this robustness is based on trimming. Trimming is exclusion of some point from clusterization. So this exclusion will make results more robust. And I need to show how it works. So first of all, this is k-means with trimming method implemented in tclust. And I will show on Aries example as usual. Aries tk is a new name from the method which called tkmeans. And tkmeans works very similar to typical k-means. So you need to take the data itself, Aries without variable number 5, which are species names, so we don't need them. You must also specify the number of clusters, 3 species, 3 clusters, and then parameter called alpha. Alpha is amount of trimming points. So, for example, 5% will be trimmed out of data. And then everything will run quite fast, as you see, and then we have a tk cluster. So we can take Aries tk object and cluster from it and see what's going on. So as you see here, there are numbers 2, 1, 3, but also 0. So what is 0? 0 are points which are trimmed out of the data, and we have points for cluster number 1, cluster number 2, and cluster number 3. What is the difficulty here, as you understand quite well, that numbers do not correspond with species names. So like number 1 is not necessarily Setosa, it might be some other species. So we have library, my own library, Shipunov, which implemented method of confusion matrix, which allows you to compare this clustering with initial species. So let me show how it works. Library Shipunov, and then we will try to take this misclassification or confusion matrix from Aries tk cluster and then compare it with initial Aries species, and then we should specify 2 more parameters. First of them is typical for this clusterization, best equal to true. So we'll be combining species names and number for searching the best composition. And then we also need to ignore cluster number 0, which is not a cluster, but trimmed out points. So ignore equal to 0, which means that points labeled as zeros will be simply ignored. And look for misclassification. Well, quite good, I would say, quite typical for k-means clustering, and supposedly these results will be more or less robust. And now I like to visualize these results, then you will understand better what is actually going on, what this trimmed clusterization means. So first of all, we need to have kind of arrangement of points. So principal component analysis is good for that. So for example, PR comp from iris without character number 5, and we need to extract the component X from it, and we'll write down in, for example, iris.p object. Okay, looks like good. So, and we now need to plot. So plot iris.p, and then we colorize points with the species. So color will be equal to iris species, and the shape of the point will be in accordance with these 0 dots which were trimmed out of data. I want you to see these dots. So PCH will be equal to if else, and then if iris TK cluster is equal to 0, then the point shape will be 1, otherwise 19. So, and you will see what does it mean. So you see now on a plot that empty dots number 1 belong to these points which are trimmed out of the data, and points which are trimmed out are, as you see, marginal points. This is actually why this method is robust. So outstanding kind of points which are separating from everything, outliers you can call them, they are trimmed out, and then a result of clusterization should be more or less stable. But we don't not see the actual clusters in that diagram. I need to show them to you. So how to show? For example, with convex hulls of this iris.p data, and I like to ignore these 0 points, so I will make kind of long thing, but you think you will understand it. So iris TK cluster not equal, exclamation mark, equal means not equal to 0. So I will take only those rows of iris.p which correspond with non-zero points of data, so points which are not trimmed out. And then I also need to specify iris TK cluster. So that was the first component, was the data. Now I should use something for making these convex hulls, so kind of factor, and that factor is exactly iris TK cluster, but without 0 points. So again, I should take out only those points which are not equal to 0. Iris TK cluster not equal to 0. And finally, this is a bit technical, but first of all, I like to have line which is a bit dotted, so LTE2. And also colors will not correspond with original colors, simply because numbers and names of species are not strictly corresponding. Function misclass will able to avoid it, but when we do hulls, we need to do it manually. I'm sorry, but I simply use some predefined colors for that, because I found this combination will look good, and I will tell you how to make colors corresponding with color of dots. So simply use the colors, use colors equal to C213. So not 1, 2, 3, but 2, 1, 3 will make colors of lines and colors of dots corresponding with each other. I hope you understand why, because any clusterization will not result in species name, but in some numbers which are not corresponding with species names. And sounds like this is a very long thing, but the idea is quite simple. As you see, I simply take out zeros. That's it. And we'll make a convex holes. Yes. And now you see convex holes quite well, and color is corresponding. So I see the clusterization is not exactly the species, and this is represented in a minimus classification error equal to 10% or even 11%. So some red dots are included in a green cluster, some green dots are included in a red cluster, and black cluster as usual stays apart. But this is a typical result of K-means clusterization anyway. And now you see how these empty dots are not within clusters, they are trimmed out. And again, results of this clusterization should not depend much on the data. So data, if data is real, if you add some more data, we don't have this for irises, but if you measure more irises, you can add it, and hopefully clusterization results will be similar. So this is how to make a robust clustering. Thank you very much.